Welcome to part 3 of my practice test 2 for statistics. Question number 7. What is the probability of obtaining 13 heads in a row when flipping a coin? And we want to interpret this probability rounded into 5 decimals. So this is the probability of 13 heads in a row. So the probability of 1 head is a half, or 0.5. And we're going to raise that to the 13th power. The way that shows up on the calculator, it's going to write it in scientific notation. So something in the format of, I rounded it to about 1.2 times 10 to the negative 4th power. All right, but writing out this decimal to 5 decimal points is going to be 0.00012. All right, so written, the interpretation of this would be the probability of obtaining "13 heads in a row is 0.00012. Okay. Question number 8. So let's say among 28 to 33-year-olds, 44% say they have not written an editorial letter while under the influence of alcohol. And suppose 6 of these 28 to 33-year-olds are selected at random. We want the probability that at least one of them has not written an editorial letter while under the influence of alcohol. Rounded to 3 decimal points as necessary, and interpreting this solution. So we want the probability that at least one has not or did not write that editorial letter. That's 1 minus the probability that none of them did, which is the same thing as all 6 of them did indeed write that letter. So 0 of them did not is the same thing as 6 of them did. This is 1 minus 0.44 to the 6th power, or as a decimal, 0.993. And the interpretation of that, the probability at least one has not written an editorial letter while under the influence of alcohol is 0.993, according to what we just found. Part B of this, is what is the probability that at least one has written an editorial letter while under the influence of alcohol? So same idea, probability that at least one has written that editorial letter. So that's the same thing as 1 minus the probability that none of them have written the editorial letter, or that all 6 of them did not write it. So 1 minus, the complement to 44% is 56%. So 0.56 to the 6th power. Typing that into a calculator, 0.997. So the probability at least one has written an editorial letter while under the influence of alcohol is 0.997. Question number 9. I have this data represents the number of drivers involved in a fatal crash in 2016 and various light and weather conditions. And I gave that table. For part A, we want among fatal crashes in normal weather, we want the probability that a randomly selected fatal car crash occurs when it is dawn or dusk. So this is the probability of it being dawn or dusk, given that this was normal weather, or whatever normal means for this. And this is the same thing as the probability of dawn and dusk, or dusk and dawn. Let me be consistent on that, actually. Dawn, dusk, and normal weather divided by probability of it being normal weather. So per this table, dawn, dusk, and normal, that gives us a number of 1,183. And if we added up this normal row, that is 29,581. So rounding this gives us 0.04. So the probability a randomly selected fatal crash occurs when it is dawn or dusk, given normal weather. Normal weather is 0.04. So if we try to flip that for part B here, I have among fatal crashes when it is dawn or dusk, we want the probability that a randomly selected fatal crash occurs in normal weather. So this flips this. This is the probability of normal weather given it is dawn or dusk. So the numerator stays the same. That's the probability of normal weather and dawn or dusk. That whole thing divided by the probability of it being dawn or dusk. So same numerator, 1,183. The denominator, though, now we add down the dawn or dusk column, and that is 1,398. So 1,183 divided by 1,398 gives us a very different probability, 0.846. So the probability a randomly selected fatal crash occurs when it is normal weather given it is dawn or dusk is 0.846. Let me know if you have any questions or concerns. Thank you.